So here we're doing essentially the same thing on the previous one, probably not as intense though overall. Just using Kirchoffs law again and using that law that each mesh, just total voltage, has to be equal to 0. We're just going to do the exact same thing. So first thing you want to do, just label all. First thing you want to do is just label, and we'll label this mesh as I1, this mesh as I2. Now let's just go. So we're walking this way, and that is a 5 ohm that I've kind of blocked out here. So 5 times I1, but wait, minus I2, because those are crossing the exact same resistor. Then you're going to have plus 2I1, plus 4, plus 2I1, and then this is going to the positive side. So positive, negative, right? So that's going to be plus 3 volts. So plus 3, because it's going through the positive side. Perfect. This one, we're on the second one. So 6, that's 6 ohms times I2. So 6. Ignore this one. We're not doing 3 at all. We're just doing 1 right now. 6 times I2. That's it. Plus, well, this time it's going through the negative side. This negative side of the battery, so it's going to be negative 5 volts plus negative 5 volts. It's a little wonky. And then plus that center one again, which is going to be 5. But again, from this mesh's perspective, I2 is going the correct way. So I2 takes the lead. Minus I1 is equal to 0. Is equal to 0. So that perspective thing is probably the one that's going to trip you most. But from this perspective, it's going through this correctly, but this one's going the wrong way. And from this mesh's perspective, it's going through it correctly, but this one's going the wrong way. So these currents are working against each other. Now this is just 2 equations, 2 unknowns. Now, what is I3 though, or I2 rather? What is I2? I label this badly, but let's change this. This is my bad. This is 3. All I2s are I3s now. I changed my mind. It'll make more sense. So if all these are I3, what is I2? I2 is the one that's flowing here. I2 is simply that I1 minus I3. It's going to be the difference between these, except it's going to be the positive one, whichever makes it positive. So, but let's worry about that later. Let's solve for I1 and I3 right now. Probably should have started that notation, but yeah, helps you out. But the other thing you gotta realize is I3, our I3 to use Kirchoffs law, our I3 is flowing against their I3. So we're gonna have to flop the I3, and again, same thing with I1. It's flowing against their expected I1. But this is the technique for meshes. This is the technique for Kirchoffs law. Once you have our I1, I3, you can easily transform it and find everything else. So let's just, this part's right, let's just solve this, and we'll go into that theory a bit more. So what you're going to get after solving it, 2 equations, 2 unknowns, you're going to get that I1, our I1, so important, is equal to negative 2 over 13, and our I3 is equal to 5 over 13. That's just by doing the mesh analysis. Now, what's wrong though is that our I3 goes against their I3, but it goes directly against their I3. So just put a negative here, and that is the real I3. And if you have I1, our I1 goes directly against their I1, so you're going to make this a positive. And there you go. That's I1, I2. What else do we know? Well, there's one more equation we need to understand, and that it's I3, the one going in here, I3 is equal to I2 plus I1. Or, yeah, these combine, or you're going to get I3 is equal to negative 2, 13. Yeah. So you're just going to add these up, and you're going to get negative 3 over 13. Or rather, no, I'm completely high. I was like, sorry. So I3 is, oh no, that's right. No wait, we gotta solve for I2. We gotta solve for I2. We gotta solve for I2. That's what's I wanna. So we're solving for I3. So I3 is equal. That is true. I3 is equal to I2 plus I1. But we're solving for I2, so it's I3 minus I1 is equal to I2. Or, in other words, I2 is equal to -7 over 13. And these are going to be your three answers. So let's just go over one more time what we just did. We did mesh analysis, so we're going to go just this way. It's just Kirchoffs law. We're going to go this way, and we're going to put, remember these are working against each other, so 5I1 minus I3 plus 2I1 plus 3 volts is equal to 0. That's the first equation. Second equation is we're doing 6I3 minus, because going into that, it's going into the negative side, minus 5 volts plus 5 times I3 minus I1 is equal to 0. Those are two equations, two knowns. We solved, and we realized that our I3 is completely against their I3, and our I1 is completely against their I1, so we're just flip the signs to get those two answers. And then, even though it was really confusing to me for a second, because I3 is usually the third thing, it's like the last thing, the combination of the other ones, but the way they did it, it's true, but we're solving for I2. So I3, we plugged in I3, we plugged in I1, and we solved for I2 to give us our final number, just by understanding what our currents were that we solved for and what the ones they wanted for in relation to each other. And that's going to give us those three answers. So now we're left with this last one, this next one. It's asking, so it says, the ammeter in the circuit shown in a figure, whatever, reads 1 amp. Find the current I1 and I2 and the value E, and E is just a voltage. So we're really doing the exact same thing once again, except this time that middle thing, because usually, like the last equation even, that middle current is on us. We have to find that. But they give that to us, and it reads 1 amp. So I can write like here. Every single time. Okay. What am I? So here is 1 amp. And this is I1. Or no, this is I2. I2 is flowing this way. And there you go. Immediately, we should notice that I1 is flowing in, I2 is flowing in. So immediately we can write, hey, you know what? I1 plus I2 is equal to that 1 amp. Because these are both flowing in to the 1 amp here. Next thing we're going to do is we're going to do the exact same thing. So we're going to curve it here. We're going to curve it here. And again, when we do this, we just need to understand what our current is compared to what it's looking for. But we're solving this. Let's solve this first. So immediately we're going to follow this along. We're going to minus 20 volts. It's going in the minus side. This is the minus side. Plus 5 times that I1. Plus, we're going to get that 8. But we already know what it is. We don't have to write I1 minus I2. We don't need to. It's given to us. We can literally just write 1 amp right in there. We know exactly what it is equal to 0. Over here, we go, okay, well, we have, and by the way, notice, this solves the I1 immediately, which is going to be important in a second here. Here, we're going around. Let's just start here, I guess, sure. We're going to get 3I2. Now, it's going to the plus side of this battery. We don't know what this voltage is. I'm just going to label it EV, because that's what it is. Plus 8 times 1 as well is equal to 0. Perfect. So we can solve for I1 immediately. And if we solve for that, we go 20 is equal to 5I1 plus 8. 20 and then minus 8. 12 is equal to 5I1 or 2.4. So we're just solving this at 20 is equal to 5i1 plus 8 minus 8 minus 8. 12 is equal to 5i1, and 12 over 5 is equal to i1. So 2.4. I1 is equal to 2.4. But wait, that's RI1. What is their I1? Their I1, so RI1 is flowing this way, but it lines up with theirs. So it is theirs. Just always check. If they were like RI1 is this way, then we'd have to flip the sign, but it isn't. RI1 is flowing this way, their I1 is flowing this way. So we can just leave exactly this, and this is in fact exactly what I1 is. Now we got to solve for I2, but we're lacking the tools well, we're not lacking tools we need. We have it right here, but we can't solve. We have to solve for voltage last because we need to solve I2 first. So we're going to bring this equation down. Say I1 plus I2 is equal to 1. We know what I1 is, so 2.4 plus I2 is equal to 1. Or I2 is equal to 1 minus 2.4, or I1 is equal to negative 1.4 amps. Is ours going the right way? Well, RI1's following this path. Oh, it's going against it. So we're going to make this plus. Opposite way. So again, RI1 is this direction. So we're following along their I1, or their, this is an I2 the entire time. Everything I said switched to I2. So RI2 is flowing this way, but it goes against their I2, so we just have to change the sign. So now we have I1 and we have I2. We still have to solve for this voltage, but I mean, you plug in I2, you have everything you need. So you go 3 times I2, which is 1.4, plus what we're solving for, plus 8 is equal to 0, or 3 times 1.4 is 4.2, plus 8 is 12.2. We get negative 12.2 is equal to this V, which is just going to become a plus because to their perspective, they're going to change that sign again. So realistically, if you get a negative voltage from a battery source, look at it more closely. It doesn't happen. But I mean, that's generally works. But the logic behind it is that again, ours is going the wrong way for I2, so we have to change these signs around. But this is going to give you the 12.2 volts. And I mean, that's your answer. Just mesh analysis. RI1 lined up with this one, so we don't have to do anything. This one, RI2 went against this one, so we have to flip it. And we also had to switch the battery because our circuit that we're doing is the exact opposite to theirs on this one. But this one, it's exactly the same. So same sort of deal. Nothing's changing, and that's everything we got to solve.